Welcome everybody and good evening. It feels like a whole year since we were, well, it's a year since we've been out to play, so to speak, or to have this important conversation. And I think, I don't think I've been back in the city since last year's kickoff summit. Really unfathomable to think about everything that's happened between. So thank you very much for choosing to brave the virus and come out here and gather in safety here tonight. And we're really thrilled to be able to talk to you here in the audience and also our large online gathering as well. So my name's Jo Chandler, and my job here is to moderate and to welcome you all to this, the very first event of the RESET.21 forum series, where over the next 2 weeks, 6 events, we'll be presenting a series of critical conversations to try and advance strategy and responses to the climate emergency. First of all, though, I wanted to acknowledge the people of the Woi Wurrung and Boon Wurrung language groups of the Eastern Kulin Nation, on whose unceded lands we are meeting this evening. And I pay my respects to the ancestors and elders past and present. Welcome to our online audience, and as I've already said, welcome. It's great to see some real warm bodies here in the audience. I'd also like to thank the major sponsors and the partners that have been will be supporting this event over the next couple of weeks. That's the City of Melbourne, RMIT University, the Breakthrough National Centre for Climate Restoration, and the Safe Climate Fund, and of course our venue partner here, the Capital, this carbon neutral theatre. Tonight's event is part of the National Sustainable Living Festival, which will be running throughout this month of February. Tonight, to kick off these 6 important conversations, we're going to ask the question around, do we already know enough about what's occurring in the climate to be able to set the right goals and timeframes for climate action? And if the climate advocacy movement is on the right track to achieve climate justice and global protection. I've heard it said a bit lately that doomism is the new denialism, and there does seem to be a deep-seated fear, many fears around the extent of the crisis and facing them, and real concern about complex solutions. And this can all in turn fuel serious doubt about our ability to respond in time. So this venue and this forum and the next 5 are really about having some really hard, explicit, brutal conversations about where we are and where we're going. So to succeed, we need to re-examine the facts with some fresh rigour and some really unrestrained, brutal honesty to form action at a level that gives us our best chance of local and global protection. Before we begin our presentations, I wanted to let you know there will hopefully be some time at the end of this for some questions from the audience. Due to the COVID restrictions and the online, combined real and virtual audiences we've got here, we'll be taking questions over slido.com. So if you want to pull up that site and submit questions, sign in and submit your questions to #RESET21. And if you see a question there that you think you would really like to see given some priority to be answered while we're on stage, then you can click on that and upvote that and give it some priority. Our first speaker tonight is David Spratt, the Research Director of the Breakthrough National Centre for Climate Restoration. David was the author of the influential book Climate Code Red, The Case for Emergency Action, which is a bit grim to say that it came out in 2008. So 12 years on, here we are still making the case for emergency action. His climate analysis and writings have appeared in many major publications in Australia and abroad, including The Guardian, The Age, Rolling Stone and the Bulletin of Atomic Scientists. So please welcome David Spratt.
Thanks, Jo. It's a bit exciting to be sort of post-Zoom and being able to eyeball people and have a conversation. So this is a bit of a moment. Towards the end of last year, we produced a report called Climate Reality Check. So I'm going to draw some elements out of that. The references and more material is available in that report, which is at climaterealitycheck.net, if you want to look at more of this. I want to start with two really simple propositions. And the first is from John Schellenhuber, Professor John Schellenhuber, who's the advisor to both Chancellor Merkel in Germany and to Pope Francis, who says political reality must be grounded in physical reality or it's completely useless. Now, that might seem an obvious thing, but often climate policy is not grounded in physical reality, and I'm about to demonstrate that in a second. The second starting point is that this is about managing risks and threats, and special attention in climate must be given to the worst possibilities, and I want to explain why. At the moment, the commitments in Paris will lead to 3 to 5 degrees of warming, which scientists say, quote unquote, is incompatible with the maintenance of civilization. Even the World Bank says it's beyond adaptation. So where we're heading will end modern societies as we know it and lead to chaos and disruption on a global scale. When you have existential risk, you don't get to run the experiment more than once. You can't trash the planet and say, oh, whoops, we've got our risk management wrong, let's have another go. So you have to be really precautionary. You can get some software wrong on a plane and the plane will crash and you fix the software and hope that the plane won't crash again. You can't do that with the planet. So special precautions are required to deal with the worst risk. So the principal point is that rather than focusing on middle-of-the-road probabilities, it's important to focus on the very large impacts. The question is, what is the worst thing that could happen in climate change and what do we have to do to stop it? So with those two principles, let me give you a very Victorian example. For anybody who likes doing FOI, there might be good FOI in this one. So a couple of weeks ago, you saw a story in the Age about sea level rises and an assessment on what would happen around Victoria and the risk if there was a 1.1 metre sea level rise in total. And that was interesting because the US government has a high scenario of 2.5 metres. And even the US Pentagon has scenarios of 1 metre and 2 metres. And Carl Braganza from the Bureau of Meteorology gave a speech to the Australian Industry Group last year where he had a map and showed that for Cairns, for example, the worst storm tide by the end of this century for Cairns should be 3 metres. So the Victorian government's looking at 1 metres, but it could be 2 or 3. And this leads to a problem which is very close to home. You know that Fisherman's Bend is being redeveloped. And the government says with some pride that it's going to have 80,000 people, Melbourne University is going to have a campus there, it's going to be livability, and then they say this redevelopment has been supported by a suite of evidence-based research. And that really drew my attention. So they have a plan and it looks like this, and there's various precincts and it's all going to be hunky-dory. If you take a sea level rise of 1.7 metres, which is less than the 2 metres that the US government talks about, and add in a 0.8 of a metre storm surge. So not only is there sea level rise, but you get winds and you get storm surges, which Melbourne Watershed could be 0.8. If you add 1.7 to 0.8, you get 2.5 metres. So that's easily what could happen to Fisherman's Bend this century. And when you do that, that's what Fisherman's Bend looks like. So this is a catastrophic failure of risk management, in my humble opinion, by the Victorian government and its planning arm in not understanding what sea level rise will do for Australia. So that's why not grounding yourself in the physical realities and not having the proper risk management approach can lead to outcomes like this. So let me go and talk about some of the things we did in Climate Reality Check. The first is that last year, 2020, was the hottest year on record at 1.27. 3 of the last 5 years have been above 1.2, and it's clear that the warming average is now about 1.2 compared to the last 19th century, to the late 19th century, and the rate of warming is accelerating. The other thing that's come out, and there's a lot of peer-reviewed evidence, is it's now fairly clear that we're likely to hit 1.5, the low of the Paris bounds, by 2030 or before. So 1.5 is probably a decade or so away. The second thing, and this is really a sort of a shocking thing to understand, and it's by a number of papers, including a guy called Samset last year. When we burn fossil fuels, a byproduct are things called sulfate aerosols, which are emitted into the air, which stay up there for a very short period of time. Sulfates have a very strong cooling impact. So what the sulfates are doing are masking some of the warming from the fossil fuels. Now, the problem is that as we replace fossil fuels with renewable energy, we also reduce the amount of sulfates. We reduce the amount of cooling that the sulfates are providing. And the consequence of that is for the next 2 decades, lowering emissions will not bend down the warming curve because the sulfate cooling is disappearing. We absolutely have to go to zero emissions. This is what Jim Hansen from NASA called our Faustian bargain. The planet should be warming faster than it is, but fossil fuels have also produced the temporary cooling, and now that mask is about to be released. The third thing is that the current level of greenhouse gases is probably enough for 2 degrees of warming. We can demonstrate this by various ways. Recently, a paper came out which said that if you just took the current level of greenhouse gases and let it run through the climate models, it's more than likely that that will be more than 2 degrees of warming in the long run. So when people talk about carbon budgets for 1.5 and 2 degrees, just don't believe them. I mean, we are on a trajectory towards 2 degrees or more. Of course, we can stop emissions, we can draw down carbon and stop that, but the current level of greenhouse gases is enough for 2 degrees of warming. And our climate history tells us the same thing. The last time it was this, we had this level of carbon dioxide, temperatures were 2 to 4 degrees warmer than the late 19th century. So if a prudent risk management approach is taken, there's no carbon budget left for 2 degrees, and we should not say so. It produces a complacency that we've got a budget left to spend when we don't. The fourth thing is that at 1.2, we're heading towards 1.5. It's already too hot. It is already not safe. If you look around the world, you can see that climate disruption is dangerous. Look at the fires last year. Look at the Barrier Reef, where 80% of it is gone. Look at the Arctic sea ice, where we're likely to have a blue water event within 10 years. Look at West Antarctica, where they say that some of those glaciers are already beyond their tipping point. No further emissions are necessary for those glaciers to disappear and push up a multi-metre sea level rise. There's debate at the moment whether Eastern Amazon is close to a tipping point, a scientific debate in the literature. There's debate at the moment whether Greenland has reached its tipping point. So some tipping points have already passed and others really close at 1.2. Climate change is already dangerous. The other thing, and this is the most downloaded paper in the history of academic climate research, was a paper called the Hothouse Earth paper released in 2018, including authored by Will Steffen from Australia. And they talked about scenarios where the feedbacks in the climate system, where climate change, for example, heat in the Arctic melts permafrost, the permafrost produces carbon, that the system can keep on going. The system can keep on warming itself, even if we stopped our own emissions. So they talk about the mutual interactions of these feedbacks driving warming further to a point of no return, where it just simply keeps on going. And they said that this threshold could exist at 2 degrees or even between 1.5 and 2, which is a frightening prospect. But of course, we're not on a target. We're not on a trajectory of 1.5 or 2. The current promises post-Paris would take us to on a path of 3 to 5 degrees of warming, which is existential for modern human societies. So the authors of that paper last year said, and I think this is a really important sentence, it really summarises the whole thing: the evidence from tipping points alone suggests that we are in a state of planetary emergency. Apparently climate emergencies even on the website of the White House these days, which is a small symbolic victory. Both the risk and urgency of the situation are acute. If damaging tipping cascades, the hothouse Earth, can occur and a global tipping point cannot be ruled out, then this is an existential threat to civilization. So there's these peer-reviewed climate scientists saying what we've been saying for quite a while longer. So this is probably the only slide you really need to remember because it's all here in one slide. So tipping points are thresholds beyond which large change is initiated. You take an ice block out of the freezer and put it on the table, it's past its tipping point because you're sitting on the table, it's going to melt. It's going to change from one system state to another. If we look at these tipping points, as I already said, there are three where we have already passed. That is for the Arctic sea ice that floats on the Arctic and fluxes in and out from summer to winter. Coral reefs, which will honestly, sadly be gone in 10 years with the current conditions, and West Antarctic glaciers. There are another three which are close at hand, as I mentioned. The Greenland ice sheet, the peer-reviewed site says around 1.5, 1.6, it will probably also tip. As Greenland melts, it pours more water into the North Atlantic. That slows the Gulf Stream. And as the Gulf Stream slows, it amongst other things, produces lower precipitation over the eastern Amazon. So this is how those tipping points connect together. And then there are the two big ones, the really big stores of carbon in the boreal forest and in the permafrost frozen ground and claterates frozen under the Arctic Sea, which are not critical yet, but they are active. So that's the story in one picture. The Arctic is now a crucial issue, and I know Sir David King will talk about this. Scientists fear privately and publicly that we are close to some really bad tipping points that will cascade in the Arctic. Professor Ramanathan, one of the most eminent climate scientists in the US, says, and this is important, losing the reflective power of Arctic sea ice will lead to warming equivalent to advancing a threshold by 25 years. The change from reflective ice to heat-absorbing sea is 25 years worth of emissions. And then he says, any rational policy would make preventing the Arctic going any further, a top climate priority for world leaders. And I think that's a really important message. And Jim Hansen, the famous NASA scientist, says, if we're going to restore the sea ice, we have to get the carbon dioxide levels, which are now at about 410, 415, back down to 300 or 325. So this sets up the sort of solutions that we need. The first is, and I know we've heard a lot about zero 2050 in the last few months, in the last few weeks. It is already too hot. Climate change is already dangerous. Our task is to build capacity for emergency emissions elimination. Mobilising for zero emissions in 10 years is crucial, really crucial, particularly in a country like us, and I'll show you why in a minute. And a 2050 time frame will not prevent catastrophic outcomes. The conclusion, and we've seen this for a long time, long-term targets are an excuse for procrastination. I'm going to stop smoking and drinking next month. It just doesn't work. That's been the whole history of policy making. You say 30 years' time and governments say, oh, I didn't be here for 3, it doesn't affect me. Why is it important for Australia? Here's a very simple explanation. The IPC has a carbon budget which, in my opinion, is too generous by a long way, but I'll just take it at face value. And they have a carbon budget with a 2/3 chance of staying below 2 degrees, which is very dangerous, of 1,170 billion tonnes. If you divide that by the world population, and you think we should have equal rights to it, in fact, we should have less rights than developing countries, but even with equal rights, that's 150 tonnes of emissions per person in perpetuity around the world. In Australia, we're doing 20 tonnes a year at the moment. So our budget, in India, that budget will last 150 years. In Australia, it will last 7.5 years. And this was from 2018. So even on the IPCC figures, our carbon budget for a high-emitting country like us actually runs out in 2025. So when you have climate advocates saying 2050, it is scientifically illiterate and ethically immoral to be saying that. I wrote a piece calling the zero for 2050 for Australia climate colonialism, because I just can't think of a better term for it. The idea that we rich people have a greater right to ongoing emissions than developing countries that haven't poured emissions into concrete and asphalt is beyond my comprehension. 3 things we need to do. The Earth is already, so zero emissions. Second, as James Hansen from NASA says, the amount of CO2 in the atmosphere is too high. We have to get it down. We have to draw down it out of the atmosphere. In fact, we would have to get from 415 back to about 350 parts per million just to keep warming at 1.2 and down further to get it back to a safe point. Sir David King, who you'll hear from shortly at his Cambridge Centre for Climate Repair, says greenhouse gas removal technologies at scale will be needed to be rolled out beginning, if possible, within the next 5 years, reaching 30 to 40 billion tonnes of CO2 per year, which is about the amount we put up each year at the moment. So absolutely reversing what we're doing at the moment. And of course, we should be wary of technologies that are not proven at scale, like bioenergy with carbon capture and storage that the Paris Agreement talks about working in 2080. And in fact, it's not proven at scale or at cost at all. The other thing, so there's a forum, quick plug, there's a forum on drawdown here a week today. The other thing we need to do is to see if there are ways of cooling the planet, because clearly there is a trajectory now which is going to take us into a very bad place. So David King, and I hope I'm not pinching all his thunder, says we need to determine how to restore damaged climate systems and the most effective strategy for refreezing the poles and the Himalayas. A number of technologies are available. Some of you might have seen a Korean guy from Harvard called Ye Tao who's talking about mirrors. He says all you need is sand and sun, which means Australia will be pretty good because you've got a lot of both. So there are a number of technologies. I don't think any of them have been proven to be of net benefit yet, but we have to keep on seeing if they can be, because in my humble opinion, they will become necessary. And there's a forum on that on Saturday week. Second last slide, just a few political conclusions. The first is that our situation is unprecedented in human history. We've never been on the edge of crashing the planet before. The second, having spent some time in Canberra, is that I think there is profound ignorance about the problem in Canberra. If you go and talk to federal politicians, to the executive levels of the public service, or to ASX 200 directors, I don't think any of them either have the knowledge or will express the reality of the crisis. If you can find one, let me know. The third thing is that gradualism is doomed because disruption is inevitable. Either we will not deal with this problem and climate change will disrupt this society from top to bottom, or we engage in a really fast emergency transition to solve this problem, which itself will be disruptive. So all the talk about this has got to be gradual, no cost, no effect on the market is simply a non sequitur. And last, here's my final thought. The Victorian Premier showed daily media leadership in response to COVID. And my question is this. Imagine a Premier giving a media conference every day for 120 days in a row to show leadership and build public support for emergency action on climate disruption. Thanks very much.
Thanks very much, David. As you were putting up those very bleak and confronting numbers, I was reflecting. I was interviewing CSIRO's David Caroli recently for a piece, and he mentioned to me that even those numbers are kind of hide another truth, and they're mediated by the fact, of course, that they're global temperatures, which of course includes the ocean temperatures. And as David pointed out in his very direct manner, humans are not fish. And because we live on land, the temperature rises that we're already experiencing and anticipating are well in excess of those sorts of global numbers that we're looking at there. So something else to dwell on. Okay, moving on now to our next speaker, who will be appearing here via Zoom, larger than life. Some will hear here behind me, hopefully very soon. Sarah Perkins Kirkpatrick is a senior lecturer and ARC Future Fellow at the Climate Change Research Centre at the University of New South Wales in Sydney. As a climate scientist specialising in extreme events, her expertise is all around heat waves. She's led pioneering research on how to measure heat waves and their changes in the observational record. Sarah has analysed how heat waves will change under various scenarios of global warming, both over Australia and globally. She's co-authored 80 publications through her career, most of which focus on extreme heat in a changing climate. And if you want to read a very accessible piece of her work, which probably isn't included in those list of 80 publications, I'd highly recommend the essay she recently wrote for Griffith Review Online, reflecting very intimately and personally, as well as professionally and expertly, about Black Summer and how that played out and what's going ahead. So I'll hand over now to Sarah.
Thanks very much for coming today. What I'm going to talk to you for the next 15 or so minutes is about the current situation of heat waves and bushfires in Australia. So they're not the only climate extremes that Australia experiences. As David previously touched on, we're prone to sea level rise, as well as other extremes such as tropical cyclones in rainfall, both intense rainfall and drought as well as changes in heat waves, fewer cool extremes, and also changes in fire weather such as the severity of the fires and also the length of the fire season. But as I mentioned, I'm just going to stick with bushfires and heat waves for today's talk. So something which hopefully most of you are aware about, but it doesn't hurt to go over this point again, is that we don't need a large change in background climate conditions to see a really large change in extremes. It's a very important relationship and it's a very sensitive relationship. All we need here is what this diagram is showing us is a small shift in the average temperatures, so that these temperatures are moving to the right where they're getting warmer, and you see a really large change in the frequency of hot weather as well as the frequency of extreme weather. So this is a very important and very sensitive relationship. Australia and the globe really has really just only warmed by about, a bit over 1 degree Celsius. But with that, we're seeing a much larger, a really noticeable increase in the frequency of things like heat waves and extremely hot days. So one way, not everyone understands this sort of diagram. This is a probability density function. I have given this slide a number of times before. Another way of thinking about this is toddlers and their very sensitive environments. This is a picture of my elder daughter when she was about 18 months old, and she used to love her bath time. She was happy as Larry in there, and it was the best time of her life. So that was her environment. That's what she was really comfortable in. But as soon as you took her out of that environment, all hell broke loose. To us, getting out of the bath is a really simple exercise, a really, small exercise. But for someone like a toddler, it's that small change in their normal environment that really means hell in a handbasket. And that's what we see when we're looking at changes in the average climate and what this means for extreme weather events. So looking at how heat waves have changed over Australia in the last 70 years, this slide is an important slide, but it's also not a good news story slide. Basically, everywhere in Australia, we've seen an increase in the number of heat wave days, which is this top figure here, the duration, so how long these heat waves last for, the number of events or number of discrete heat waves we see in a year, as well as the heat that they generate, as well as the bushfire, as well as the heat wave season as too. On top of that, the timing of the first event is occurring earlier each year. So generally speaking, the heat wave season could start around November or December, depending where you are in Australia, but now it's actually starting to occur a bit later and leaking more into springtime as well. So these trends are over the last 70 years, but especially over the last 40 years, these trends have really started to ramp up, which is when the amount of greenhouse gases in the atmosphere has accumulated more and more. Something that I do want to drive home, though, is changes in Australian heat waves are particularly specific to a location. So, for example, some places in Australia see a much higher change in the frequency of heat waves or the number of heat wave days, such as Canberra. They've seen a doubling in the number of heat wave days over the last 60 or so years, but they haven't really seen a change in the average intensity of heat waves. However, somewhere like Melbourne, for example, has seen a drastic change in the timing of the first event per year, as well as the peak intensity or the hottest day of the heatwave, but they haven't seen as much change in the number of heatwave days compared to Canberra. So while we are seeing these really drastic changes, the exact amount of these changes will depend on what location you're looking at over Australia and that the endemic climate there too. But the fact of the matter is, and I'm really driving this point home, that no matter how you measure extreme heat, it's been increasing for the last 70 years, and at least going to this graph, which was produced by CSIRO, almost really for the last 100 years. And that change has certainly ramped up in the last 40 or so years. Unfortunately, future projections from climate models are looking pretty bad. From what I could hear from David's talk previously, he was talking about emission scenarios, and this is what we're using when we look at future climate projections. So if we look at a middle of the road scenario, which is where warming might reach around 2 to 3 degrees Celsius by the end of the century, we will still see an increase in heatwave days as well as their intensity, but is obviously less than the business as usual scenario. So business as usual basically means we just keep doing what we're doing. Greenhouse gas emissions just amplify up until at least the end of the century. And we're looking at a warming of around 5 degrees Celsius globally. And you can see here that means really large increases in the frequency of heat waves in Northern Australia and really large increases in the intensity of heat waves in Southern Australia. And this is already the region down here in Southern Australia that experiences the most intense heat waves already. So unfortunately, they're just going to get, up to 4 to 5 degrees worse than what they currently are. Now, there is a really strong relationship between global warming and the severity of Australian heat waves. This is a really neat diagram from a recent study. And it's basically shown that for every threshold of global warming that's important relative to the Paris Agreement, this is indicated by the colours here on the right, we see a much larger increase in the duration and number of heat waves. So if you look at the red, that's looking at the global warming scenario of about 3 degrees Celsius, which, if we do live up to our Paris pledges, this is where we're heading. And you can see here, although there's a lot of spread among the model projections, there is a significantly larger change in the duration of heat waves as well as the number of events relative to the other two global warming scenarios. So this is really quite a striking result. Not only is it telling us how bad it can be over Australia, but it's also telling us that if we can somehow limit our global warming, we will absolutely see a reduction in the number and duration of heat waves relative to what will happen if we warm by 3 degrees Celsius. And this relationship here is obviously being proven for Australia, but it's also quite similar in other parts of the world in the sense that global warming is a good predictor of how heat waves will look at in the future. Something that we tend to do, or I guess this is a really exciting but also quite new part of climate science, is identifying the human signal behind recent events. This is where we look at any given event, and I've got 3 examples there on the right, where we look at that event, define it somehow, and then work out how often that event occurs with climate change versus looking at it in climate models without climate change. And then we get what we call the anthropogenic signal. Now, this is really interesting, and it tells us a lot of information that, yes, that event has increased in its intensity and frequency because of climate change. But the exact signal is specific to the event that we're interested in. So, for example, if you're looking at the angry summer here, which is the top figure on the right, the signal behind that event is very different to the heat wave we had in May in 2014, which is very different to the marine heat wave it experienced off the coast of Tasmania at the beginning of 2018. Also, the signal can vary a little bit depending on the climate models that you might use to find this signal. But one thing that I'll put my hand on my heart and say is that no matter what heat wave we look at, there will always be a signal because of climate change. That is absolutely clear that every heat wave we now experience is more likely and or more intense because of climate change. And that's something that we need to keep in mind when we're communicating this message. Just to drive that point home a bit further, this diagram is just showing the likelihood of coral bleaching in climate change. So if we didn't have climate change, the coral bleaching that we experienced in 2016 wouldn't have happened. Those sea surface temperatures that caused that event just didn't happen. But as we warm in the future, especially if we reach 2 degrees Celsius, that bleaching is going to occur a lot more often and almost pretty much every year in this situation. So moving on to bushfires now, it's probably no surprise to most of you there that bushfires are also worsening. The figure on the left from CSIRO is showing the change in the number of dangerous fire weather days. You can particularly see here that off the east coast of Australia as well as southern Australia, there's quite a large change in the number of these sorts of days, so up to 25 days extra per year. On top of that, the bushfire season is lengthening, Here, this is showing changes in the bushfire season relative to different seasons of the year. And we see the most marked change in spring, particularly over southeast Australia. So that's the bottom right figure. We're seeing a much larger increase in fire weather during that season over that part of Australia. And that kind of plays into the events that we've seen over the last few years as well. This is not just a result for Australia, this is very consistent globally. We're seeing an increase in the length of fire season, so this is a globally average result here. And the area affected by these long seasons has also increased. So this is not just for a little region over Australia and a little region over America. It is a large global result that fire seasons are lengthening and they're affecting and burning more areas because of that lengthening in the season. Extreme bushfires are also increasing in frequency and severity. So if you think of the 2009 Black Saturday fires, last year's Black Summer fires, they're these extreme pyrocumulonimbus fires, so the ones that form their own weather systems. They're increasing much more often, and in this case, this figure is showing the interval or the waiting time for these sorts of fires in Victoria over a 110-year period. And you can see here that basically the frequency of these fires has about doubled, which also means that the waiting time has halved. So they occur twice more often than what they used to at the beginning of this century. The atmospheric conditions that are conducive to these sorts of, really catastrophic fires is projected to unfortunately increase in the future too. So this is a result from a colleague of mine at UNSW Canberra, but it's been replicated in other studies as well, that when you go further into the future, days of high atmospheric instability are much more common, and which that's the highest type of atmospheric instability is indicated by these yellow bar charts here. So going forward in time, it does get worse, unfortunately. So we are more likely to see fires like Black Saturday and Black Summer as climate change intensifies. This figure or this slide is also, playing into that sort of result as well. On the left column is showing spring, and the rows are showing changes in very high fire danger weather and also extreme fire danger weather. So that's when you get a total fire ban. Now, interestingly, we're seeing these changes occur more often in spring, and there's a particular region in Australia in the southeast where these changes are the most prominent. So you can see that in both types of fire metrics. We are seeing a slight increase over other parts of southeast Australia as well, but it's especially this region over Victoria and southern South Australia, where there's quite a pronounced increase in both very high fire danger days as well as extreme fire danger days. So this is what, potentially where we need to put our resources in when we're trying to plan and adapt to future climate change and the bushfires that will result from that. Recent work from a PhD student of mine is demonstrating that we do get higher incidences of heat waves and drought mean higher incidences in fire conditions. So again, he was looking at the southeast Australian region, and this work was spurred on by last season's catastrophic events. And he found that over the far southeast corner of Australia, the change, longer heat wave days and longer heat waves generally means that the fuel that goes into the fires dries out more quickly, and then you're much more likely to have really intense bushfires. Whereas if you look at the northeast parts of Australia, the average intensity of heat waves as well as their peak intensity tends to dry out the fuel more quickly and then also equal really bad bushfires. Now, in a case like last summer, heat waves were really long and they're really intense everywhere, so everything kind of came together to create that perfect firestorm. But certainly this is a very interesting result as we haven't really been able to link the two types of extreme events previously. So this is just my last slide of data, and it's all getting really bad and it's all really bleak. But something that I really wanted to drive home, and I did touch on this before, is that the amount of global warming matters. So I mentioned earlier that over Australia, heat waves and global warming do correlate quite nicely. This isn't just the case for Australia, it's the case for pretty much everywhere in the world too. And you can see that with various different regions on these graphs. If we warm by, half a degree less, so if we're aiming for if we're on the track for 3 degrees now, but we only reach 2.5 degrees, we'll see a much, clearer difference in the frequency, severity, and duration of heat waves basically everywhere in the world. So while 1.5 or even 2 degrees is probably not looking that likely anymore, it's still better to do something than nothing at all, because we will see a marked difference in the extreme events, not just over Australia, but globally as well. So with that, I'll leave it there and hand it back to Jo.
I think if any of us had been distracted this last few months by coronavirus and then by this gentle La Nina summer, you've put us back on course to understanding what we're actually dealing with now. Something of a, I won't say it's a shock to the system. So many of these things, any of us who are paying attention and reading, it's all familiar, and yet when you see a presentation like that, it just really, I think it just kicks you in the guts, doesn't it? So thanks very much, Sarah, for that. So now we're going to move from fire to ice. It's not going to be a whole lot more reassuring, though, I suspect. So our next speaker, again zooming in, larger than life, will be Sir David King. Sir David King is the founder and chair of the Centre for Climate Repair at Cambridge, an Emeritus Professor of Chemistry at the University of Cambridge. Formerly in the UK, he was the chief scientist, scientific advisor to both the Blair and the Brown governments, a senior strategy advisor these days, I believe, to the president of Rwanda. Lots of interesting things occurring in Rwanda. He served as founding director of the Smith School of Enterprise and the Environment at Oxford University from 2008 to 2012 and was the head of the Department of Chemistry at Cambridge University from 1993 to 2000. So please welcome Sir David King.
Thank you very much. So let me just start by taking the first slide, the next slide. If I could have the next slide, please. Okay, thank you. So in blue on this slide, all I'm showing is the average carbon dioxide levels in the atmosphere as measured going back in time by various means, but since the 1950s, measured very accurately. And what we see is the carbon dioxide levels are now at 415 parts per million compared with about 275 back in 1700. And if I then say, but that is not the figure we should be focusing on, although it is what the majority of people seem to focus on, because we need to look at CO2 equivalent, adding in other greenhouse gases. And if we do that, what we come to is a CO2 equivalent level of 500 parts per million. And I'm saying this because years ago, 25 years ago, the science community was saying we must never exceed 450 parts per million. The reason why this is going up so quickly is very largely methane emissions, and methane emissions are rising very rapidly because of the big new global demand for livestock, meat in particular, and for rice. And each of these are big methane producers. And we know from isotope analysis that the big rise in the last 15 years in methane in the atmosphere has been from livestock rather than from gas emissions from oil and gas recovery. So that's the first point, that the situation is already extremely serious. And my main message is going to be where we are today at 500 parts per million is too high, and we have to actually deal with that situation. If I could have the next slide, please. Here, this follows very neatly on from what Sarah has just so well presented. Back in 2014-15, I ran a major project with the governments of China and India in particular on risk analysis. And risk analysis is looking at extreme events because it's extreme events that lead to massive human suffering. And what we did was work with Chinese and Indian experts. I signed MOUs with both governments, and we had something like 100 experts working for 8 months on this project. And these included people from the military, people from the security services, and politicians. And what we concluded from this is really quite frightening, because if we just extrapolate forward 5 or 10 years from where we are now, we can see major risks emerging, perhaps unexpected, such as rice crop failure, causing massive problems with feeding the populations in Southeast Asia and China. So if we now move forward, that was a program that was run in the run-up to Paris COP, and the intention, of course, was to get those countries to focus on the massive risks that climate change represented for them going forward in time. And I think it was extremely successful, and both countries have run those programs forward in time to the present day within their own countries. Next. This is just to say that in Papua New Guinea and in the run-up to the COP21 meeting in Paris, I was representing Britain at that meeting of heads of governments of the island nations, and the Australian and New Zealand prime ministers were there alongside the island nation heads of government. And this is where the United Kingdom made a change of position, and we backed the island nations who were calling for 1.5 rather than 2 degrees as the objective in Paris. And of course, as you've just seen from Sarah's presentation, there's a very big difference in risk analysis going forward in time between 1.5 and 2 degrees. Next slide, please. Thank you. Now, this is an important part of what I want to say. On the first day of the COP meeting, this photograph was taken of the heads of governments of 22 countries. There are now 25 countries have joined Mission Innovation. This is a program that I began work on 4 years ahead of that time in 2015. And this was the triumphal moment when all of these heads of government stood under the banner to commit themselves to raising $30 billion of public money to be spent on finding the alternatives to fossil fuel systems around the world. And this is public money to go into research, development, and demonstration, largely in the universities of the countries represented. As a matter of fact, last year, 2020, the spend was $23.5 billion amongst those countries. We didn't make the 30 billion because President Trump withdrew the difference. But Biden has already said that the difference will now be made up and will be increased. Mission Innovation runs ahead now. At the last Mission Innovation Ministerial meeting, it was agreed that this should be continued to 2025 and the ambition should be raised to $40 billion. Now, I believe that's not enough. We need more because we need rapidly to move away from the old technologies that we've had to replace them with post-fossil fuel technologies. And let me say, I believe this is the biggest wealth creation opportunity the world has seen since the Industrial Revolution. Energy is the biggest system in the world. And as we replace that, there are hundreds and hundreds of opportunities for innovators to come into the marketplace and find these new solutions and take them in. So let me just move on from that. I'm going to come back and mention Mission Innovation again. The next slide. This is just one example. This is a British company working on developing an airship that uses absolutely no fossil fuel at all. This is an airship designed to take freight, and what you see in blue underneath the aluminium shroud is the freight carrying device. It can take 150 tons of freight. That's an enormous amount. And the airship is lifted by releasing helium into 12 chambers under the aluminium shroud. And as the helium is released into the helium balloons, it rises to roughly 30,000 feet. It's not too sluggish then, because at 30,000 feet, air density is low. And so it travels fully loaded at about 250 kilometers an hour. And those engines on the side there are Siemens electric engines. This is very large. It measures 175 meters by 75 meters, and it's covered with photovoltaics, which means above cloud cover in sunlight. It can drive entirely by electricity generated in that way. Next slide. Now, I'm just going to say this is what is happening in a way much more quickly than the climate science community believed it would happen just a few years back. So what is happening is that the North Pole is becoming denuded of ice, during the polar summer. And it means that more than 50% of the Arctic Sea is now exposed to sunlight during the Arctic summer, and the whole of the Arctic Circle region is now heating up at about 3 times the rate of the rest of the planet. So whereas the rest of the planet is now at 1.1, 1.2 degrees above the pre-industrial level, the region shown here is now at about 3.5 degrees above the pre-industrial level, with extreme temperatures being observed, for example, in northern Russia during the past polar summer. When I say extreme temperatures, I'm talking about 20 degrees centigrade or more. The polar vortex is distorted and meandering, which means that in the northern hemisphere, we're experiencing very strange weather cycles. And on the right-hand side, something we've all been worried about, which is methane being released from permafrost. And we're now finding that methane is being explosively released. Around 1,000 to 2,000 explosions have occurred, and each explosion leaving a crater in the permafrost about 50 meters diameter and 60 meters deep. So the problem is it's not just slow leakage, but a rapid explosive release when a large methane bubble is formed under the ice cover. So here's the big challenge, because on the left-hand side, we've got Greenland sitting in the Arctic Sea. And so Greenland is now heating up also much more rapidly. And when all of Greenland ice melts, global sea levels will have risen by 7 meters. Now, of course, it's going to take a long time for that to happen. But even by the end of the century, we can foresee something like a 2-meter sea level rise simply due to this cause. And by the mid-century, we're going to see significant problems from this. Next slide. These are the explosive releases that have been already observed in northern Russia. Next slide. So we have to recalculate flood risks in Southeast Asia in particular, a region of the world that suffers from extreme hurricanes, and hurricanes are becoming more and more intense as the ocean sea surface temperature increases. And so what you see on the left-hand side is the old projection for 2050 for Vietnam, a major risk area because it's all quite close to sea level. And the Mekong Delta shown there is the region of the world's biggest rice paddy field. And of course, if the rice paddy fields suffer from sea incursion, they will no longer be productive for rice. But on the right-hand side is the new projection based on the observations I've just explained to you. And you'll see that now the flood shown is the annual flooding of the Vietnam region. And you'll see all the way up to Ho Chi Minh City, there is massive flooding. The net result is that, for example, Jakarta in Indonesia is going to be so seriously flooded that they will have to move to higher land. And cities like Calcutta and Mumbai will also be severely flooded and probably unlivable. We're looking at a region of the world that by mid-century will have something like 300 million people looking for somewhere else to live. Climate change migrants are going to be the big new challenge of the region. Next slide. So we've established a Centre for Climate Repair at Cambridge, and I'm just going to explain what we mean by climate repair. And of course, what you'll see from this is yes, it's ambitious, but I'm also saying it's necessary. This is a strategy for handling the situation that we now have. We want deep and rapid emissions reduction. We're cooked without that. We must also create new greenhouse gas sinks at scale to restore the atmosphere from 500 parts per million to less than 350 parts per million of carbon dioxide equivalent greenhouse gas level. Now, that's an enormous challenge. We believe we will need to remove something like 30 to 40 billion tons of greenhouse gases per annum to achieve this, and that is the objectives that we are setting ourselves. But we want to work with partners around the world, and I'm delighted to be talking to you here in Australia, because we need partners in Australia as elsewhere. The third one is the one that raises most eyebrows. We are looking at technologies and methods that we might be able to use to refreeze the poles. And this, I believe, is necessary because we need to halt the loss of land-based ice in the polar regions and also the Himalayas. Finally, the fourth objective is to promote agile political, business and investment responses. Unless we get a response from those three large global communities, we're not going to manage the problems ahead of us. Next slide. So here is, first of all, I'm taking the last of those, the political actions, national actions, which have been reasonably successful. It's much easier to get national than global actions. International cooperation, we have seen coalitions of willing nations. Mission Innovation is an example of that. The European Union has recently announced a €1 trillion green finance budget over the next 10 years, which I think is only a beginning. And then thirdly, we have the global agreement, the COP21, which we haven't stuck to at all. And finally, Mission Innovation 2 is now going to be established in Chile in June this year. And let me just emphasize that Australia is a member of Mission Innovation. And we need to get much more action from the Australian membership of Mission Innovation. What we need to see is that Mission Innovation begins to move towards taking on, amongst those 25 nations, political action, such as jointly moving on carbon pricing going forward in time. Next slide. Greenhouse gas removal technologies, our biggest focus, and as I say, we are acting as a global hub to get many different places in the world focused on these technologies. This is just a list, a long list: reforestation, etc., carbon capture, utilization and storage. We are focused on marine-based technologies, marine permaculture, but also in particular deep ocean fertilizing. I'm going to say a little more about that. Iron salt aerosols, or in particular zinc oxides coated with silver photocatalysis to remove methane from methane emitting areas. In particular, we're focusing on old coal mines, which is a big source of methane here in the United Kingdom. And then finally, direct air capture. And there we're looking at devices for direct air capture, which do not involve using fans and therefore large amounts of electricity. New slide, next slide. All right, the focus for us is on the feasibility of the projects, technological feasibility, scalability. We're only keen to work on projects where there's a capability of removing 1 billion tons or more of carbon dioxide per annum. We, of course, need to look at cost and how we can offset the cost through any sales from products, and then real focus on potential adverse impacts. Obviously, we shouldn't proceed if there's a major potential adverse impact from any of these new technological interventions. Next slide. So here's one of our favorite interventions, ocean surface iron fertilization. We're working with 3 universities and institutes around the world: the Goa Institute in India, the University of Hawaii, and the University of Incheon in South Korea. Be very happy to have an Australian partner on this. The ocean surface iron fertilization imitates a natural process. It creates a green layer on the ocean surface, maybe 10,000 to 100,000 square kilometers at a time, with very dense phytoplankton. And phytoplankton is, of course, the feedstock for fish larvae hatching from fish eggs. The oceans are full of all the other nutrition required. They just need the iron to fertilize this whole process. And the net result is large carbon dioxide uptake, as with any land-based forest, and a massive increase in ocean fish stocks. So here's the process. Would be, once we've checked that there are no bad ill effects, to deposit iron on the ocean surface in the deep oceans of the world, roughly 2 to 3% of the ocean surface every year, we believe would take up about 30 billion tons of greenhouse gases a year. So this one technique could deliver a very big part of what we're aiming for. Next slide. Solar radiation management has been much discussed, and we are focused heavily on marine cloud brightening. I'll just show a figure of that. We're working in particular with a marine engineer based in Edinburgh, who has developed a very clever zero energy input technology for developing this technique. And we also have a project on stratospheric aerosol injection. We believe that stratospheric aerosol injection should not proceed at the moment. We believe there should be a moratorium on that. Only in extreme events should we have to go back to aerosol injection. It's an extreme measure to take. And let me then move on to the next slide. Interventions. Here's cloud brightening with the engineers' first attempted design at causing bright clouds to appear over the Arctic region during the Arctic summer to reflect sunshine away from the ice formed in the Arctic winter, to see that it isn't removed during the Arctic summer, and then we can see layer by layer growing on the Arctic Sea moving forward in time. Next slide. I just leave you with this notion. We have to move rapidly. What we do over the next 3 to 4 years, I believe, is going to determine the future of humanity. We're in a very, very desperate situation as we sit now. We have left this very, very late. We can still manage it, but we have to operate along all of the directions I have suggested. Thank you.
Thank you very much, Sir David. I'll come directly to you off the back of what you've just presented to us. And again, it put me in mind of a conversation I had with our CSIRO's David Caroli quite recently, which is in an article that I've got that will be published shortly, where he was talking about the geoengineering drawdown prospects that were beginning to look inevitable in the response to this emergency. One of the concerns he had was that the Northern Hemisphere, which has the historical, political, economic might to get this moving to, I guess, save that hemisphere, might be looking to deploy a lot of these measures in the southern, the global south, where we have the oceans, fewer people, and economies and political might that are not quite equivalent. He was concerned that the south may suffer disproportionately by the attempt to fix some of these problems. I wonder whether you have any thoughts or concerns around that.
Yeah. Let me say at once, there is no technology we will roll out that would cause any significant damage anywhere in the planet. But at the same time, if we don't roll these programs out, we will continue to cause the massive damage, not only to land-based systems around the world, as Sarah has very clearly presented, but also to the oceans of the world, where fish stocks have dramatically decreased and where pollution is occurring at a major level. So what I'm actually saying is, we are trying to develop carefully processes that we can use that can reverse all the damages that we are creating today, instead of continuing to make it even worse. Now, it is fair to say that we are fully focused on naturally mimicry, natural mimicry. So if I take ocean iron fertilization, how does that occur in nature? There are two ways. One, when the wind blows over a desert, such as the Sahara, it picks up very small desert sand particles and creates a dust storm. And if the dust storm goes over the Atlantic Sea and then dies down, it peppers the Atlantic Sea with these dust particles from the desert. They contain iron, that's why they're yellowy red in color. They contain iron, and the iron fertilization process may proceed over an area of 100,000 square kilometers. It causes greening. It gives rise to massive fish levels, perhaps billions of fish, and even the big whales come in. A blue whale will come in and take up 1 million fish in one mouthful. So this is a process that re-enlivens the ocean. It re-establishes ocean forests, which are themselves big biosystems. And that's all we are trying to do in that case.
Geoengineering is scary at many levels, and I guess what Sir David has referred to here is a spectrum of risk, from things that would appear to be maybe fairly benign in the scheme of things to things that are off the table at the moment, like aerosol injections, until we assess the consequences of that down the track. I'm just wondering how palatable you're finding that conversation, and whether you have concerns that the global south might suffer disproportionately from the efforts to save the north.
Well, the global south is suffering in many ways already. Obviously, the impacts of climate change disproportionately fall on those who don't have the economic capacity to respond. Hence, you see the problems are going to arise in Asia, where there's, the UN is saying there are 1.5 billion people in the world now who suffer from chronic water shortages, and that will get worse. So David King talked about a 2-metre sea level rise. A 0.5 metre sea level rise will inundate 20% of Bangladesh and displace 30 million people. So when we look at maps about, bits of Altona being underwater, this is trivial compared to the problems that are going to be in the south. I think that some forms of direct cooling are inevitable, simply because if we don't do it, we won't be here. And we are now in a world of least worst options. We might say morally we don't want to interfere with the climate, but we've actually been interfering with the climate for 150 years. Obviously, these technologies need to be proven to be of net social and environmental benefit. And he was clear there that we've got to be quite precautionary, making sure these things are going to work and not have terrible adverse consequences. I think the big fear is, as things get worse, that countries will unilaterally do it. I mean, 2 of the countries that will be most affected at scale are China and India, by water shortages in particular. They both have... China has 20% of the world's population, 7% of its potable water supply. If there is not discussion and some international governance developed around these technologies, people will do it by themselves. And that's a problem. I think they are necessary to be done. I mean, as Sir David has pointed out, we have over 400 parts per million of carbon dioxide, 500 with the other gases. If we stay at just that level, and we're still emitting more, if we stay at those levels, we will get to 3 or 4 degrees of warming. And, 13 years ago, some US national security analysts said, if you get to 3 degrees of warming, the world will be characterized by the phrase, and they said, outright chaos, the breakdown of nations and relationship between nations. So we are in a world of least worst options. And I think the important message from Sir David is that real large resources, what he's trying to do, many others are trying to do, is trying to work out what technologies may work. We shouldn't jump the gun, but if we don't think about what might work, we're going to be in a much worse place.
I have a question also for Sarah. I was interested in the slides where you were talking about attribution and the signature, the human signature. And I remember a few years ago, one of the things that we kept getting stuck on in terms of progressing on action was we can't really know what is human-caused, climate impact and what is natural variation. And in that lovely essay that I referred to that you've recently published, you talk about the seesaw of of Australian temperatures, the classic droughts to flooding rains. And I'm just wondering how solid now is the signature around how wild that ride on the seesaw is becoming as a consequence of human action. Are we in a lot of this conversation is around how many facts do we need to nail down? Do we have the facts? And I guess I'm just wanting to know, how solid are we now on the human signature around what we see playing out?
Okay, so yeah, so when it comes to attribution science, we're certain that any changes in heat extremes are due to climate change. Now, as I said, the exact signal depends on the event that we're focusing on and the approach that you use, but I would happily mortgage my house, happily bet on my children's life that any sort of heat event that we experience has a signal of climate change behind it. Now, when we talk about that signal, we're talking about its frequency and or its intensity, so how often it occurs or how hot it might be. We're not talking about the categorical, did climate change cause this event? That's not something we can determine, because any event, whether it's extreme, short-term, long-term, etc., is a confluence of many different factors. So things like natural variability, like El Nino or La Nina, things like synoptic weather systems, other mechanisms such as interactions with the land surface or in the ocean heat content, or budgets or eddies or currents. They all work together to cause that extreme event. But what we know about certain types of extremes is they're enhanced, they're on steroids because of climate change. So I go back to the toddler in the bathwater kind of situation. Some extremes, yes, like heat waves, we can find that signal more readily. Other extremes, it's harder because they're swamped with that variability signal. So that's generally when it comes to extremes around rainfall. So tropical cyclones or thunderstorms or extreme flooding events or even droughts as well. Particularly in a place like Australia, it's not necessarily the case worldwide, but we have such a variable climate, and we will continue to have a variable climate with climate change. It's just shifting towards a warmer state. So we will see these rainfall extremes, and the science, the theory around the fact that a warmer atmosphere can hold more water, that's absolutely true. But at least currently, a lot of those extremes are swamped in that sort of variability signal. Was it mainly due to an El Nino or La Nina, or was it mainly due to climate change? That's a little bit harder to detect. I would argue very, very heavily that the signal is absolutely there when it comes to rainfall extremes. It's just harder to tease out, and we just can't do it, I guess, with as much confidence as we can currently for heat extremes. But certainly there'd be a signal there. How variability is going to change with climate change, there is evidence that El Nino events will become more intense. So when we have that sort of active phase of climate variability, at least for some modes, they will be worse effectively. So, supercharged El Nino, supercharged La Ninas. And currently La Nina is warmer than what El Ninos used to be pre-climate change. So even though they'll be cooler than what we the current average, they're still going to be quite hot anyway. So you can think of the sort of rainfalls extremes that will fall with that. So there's a lot of certainty that yes, it's, these extremes are being caused by climate change, and we'll continue to have that variability. There's obviously some things that, the science needs to work out. I guess the devil's in the detail, but there's pretty solid evidence moving forward that, things are getting a lot worse, basically, and we're pretty confident in that.
I read a piece in the London Independent last week, and I guess I'm fact-checking its report of what you had to say there. It said that you had reflected that you had advised the UK government not so many years ago that 1.5 was, a safe limit, but that you had since more recently reflected and decided that position 1.5 was wrong, and that the Arctic tipping point has already been crossed. I'm just wondering whether that's an accurate reflection of your thinking at the moment, and whether you could talk a bit more about that Arctic tipping point and when we passed it.
Okay, so I think the question is, I've been saying that 1.5 tipping point has already been crossed, and this is my current thinking. Yes, what I've described as happening in the Arctic Circle region is also happening in the Antarctic region, so please don't think this is just a Northern Hemisphere phenomenon, but is also happening in the Himalayas, and each of those has a dramatic influence on populations of the world. I say that because each of them gives rise to very significant contributions to the sea level rise, which is much more than we anticipated even 5 years ago. So yes, I'm afraid the tipping point in that respect has been passed, and therefore we have to reverse these processes. This is, by the way, isn't just my current thinking. This is where the science is telling us we have got to. The modeling of ice melting has been really misleading, in the sense that if you take an ice block out of a freezer and put it on a saucer and watch how it melts all around the edge of the ice block, whereas what actually happens in practice with these very large chunks of ice is that they form lakes on the surface, and as the lake deepens, it goes bluer, absorbs more sunlight, and so the melting accelerates as a function of time, which certainly doesn't happen with an ice block. And in a way, that's where the calculations came unstuck. They didn't predict the complex nature of the melting process that is occurring at both ends. And by the way, in the Antarctic, the melting is very largely from underneath the ice because of the warmer sea level, and the water getting between the ice and the land is where the melting is occurring. So in each case, very different and very challenging to calculate.
Thank you.
Just to follow up, it's really clear that certain tipping points have already been passed at the current level of warming. For example, in 2014, a paper came out by Rigor et al., where they said they had determined that there were various glaciers in West Antarctica that had passed their tipping point. That is, no more greenhouse gases were necessary for them to keep on melting until they weren't there. And we asked them, when did they think that tipping point happened? Because you don't see tipping points essentially in retrospect. And they said probably at the greenhouse gas levels of the 1980s. Because you don't see, it's only after the accident that you see the accident. The other really interesting issue is the Himalayas. Recently, some people discovered some, I think, Cold War era photos of the Himalayas. They managed to compare them with contemporary photos, and they've decided across the Himalayan range, the Hindu Kush and up Tian Shan Mountains, that whole area, that roughly 25% of the ice mass is already gone. A quarter of the Himalayas is already gone, and it's losing mass at about 1% a year. So by in another 20, 25 years, half the ice mass there will be gone. And as we know, the 7 great rivers of Asia, through China, through India, through Bangladesh, through Southeast Asia, all rise in that mountain chain. So this is really catastrophic. And this is not a future thing. This is a thing which is now already well in progress, which I think why Sir David, amongst many others, is saying climate change is already dangerous. It's not something in the future.
I think that's become a bit explicit this evening. So now will we try for some? We can.
Yes, we've got a question from the audience. It was the most popular one on Slido. It's for David Spratt. I work in local government. What's my priority? Drawdown, emissions reduction, or adaptation?
This is the walk and talk and chew gum at the same time. I think the most important thing is, first of all, for local government itself, both the councillors and the professional staff, to fully grasp the problem. We have to start with an understanding of the problem, and I think that comes first, because you can write all sorts of policies only semi-informed and they won't work. So I think that's the first thing, that working in with the council to be really up to scratch. We've seen what happens with my little sea level rise of Fisherman's Bend if you start making policy without a sound base. After that, obviously in the local government area, the most immediate issue is emissions reduction, because the council has got emissions. There are emissions in the community where many of the solutions are available. But I think all levels of government should particularly say to high levels of government, but these other things are important as well. Always say it is not just one. We need all the medicines, all the fixes we can get, not just one.
Got a question for Sir David. Do we have modelling on the impact of agriculture and food production of the predicted changes in temperature and rainfall?
Okay. So basically, I'm answering the question about the impact on agriculture and food production. And we in that work that I referred to, the risk analysis done in China and India with those two governments, I took with me a group of people from the reinsurance sector in the City of London who are used to calculating risks. Not everyone is as good at calculating risk analyses as Sarah. And so we took along these experts on risk analysis. And what we did was put to the two governments, what are the biggest challenges you think climate change may bring to your countries? And one of the answers was from the Chinese government, rice production. What is the probability that rice production across the whole of China fails in 1 year, which obviously would be disastrous? And we calculated the probability of that happening, and it turned out that at the moment that probability was as low as your house burning down. It was a very, very low probability. But a 0.5 to 1 degree temperature rise above the level that was then in 2015, and we find that probability rises to something like 1% in a given year. And as you move up from that level, with every 0.5 degree rise in temperature, you go up exponentially in risk, so that it becomes very likely it will happen in every year with a 2 to 3 degree centigrade temperature rise. So what we concluded from that, and by the way, that is just using some input from agronomists. The rice plant, as it's flowering, is very sensitive to temperature. 3 days at above 32, 33 degrees centigrade, at that point in time, it no longer produces any fruit. And so we use that as the temperature analysis. Now, of course, you may produce better rice plants, but the second challenge to rice production is from incursion of seawater, and then you need saline-resistant rice to be able to continue to use the same paddy fields for rice production. So the answer is yes, you can do risk analyses on all of these things, and that's what the insurance and reinsurance sector is all about.
Thank you very much, Sir David. And I'm going to have to draw a line under the conversation here because we're well out of time. I hope you can forgive some of the glitches that we've seen here with the communications. Welcome to my world. This is what teaching in the age of Zoom has been like for me for the last year. But I'm hoping the calibre of the speakers, the calibre of the insights and the power of those presentations will be resting with you all. So thank you very much, Sarah, Sir David and David. Thanks for coming.